What is up, boys and girls? We're going to continue with Blocker, the amazing blockchain. We're going to build completely from scratch. And yeah, it's going to be the real deal. Teams of 4 to 8 people are trying to build this stuff, completely funded with millions by the market, because people are thinking they're going to create the next big thing. And they still cannot deliver this stuff. And we are going to single-handed build a complete blockchain that's actually going to work, because we are from a complete other level. All right, so we actually, the previous episode we started with, we created the basics of the UTXO, because we're going to make a UTXO blockchain. Let me clean my keyboard real quick. UTXO blockchain, because I think it's important that you guys know how that all works. Yes, so today we're going to basically set up our GRPC server. We're going to use GRPC as our transport, right? So what I'm going to do is I'm going to create a new folder. And I have this micro CD once again. I'm going to create a new folder, and it's going to be... how are we going to call this? Server maybe? Or node? Normally I call it server, but this time I think I'm going to call it node. Not quite sure, hey, but it is what it is. We're going to create a new file. It's going to be nodes.go. We're going to say package node here. Yes, just like that. I'm going to say type node, which is going to be a structure. To be honest, should we call it node? I think I'm going to call it server, to be honest. I'm going to call it server. Not quite sure. So I'm going to rename this stuff real quick. Server.go. Right, and then I'm going to change it up here. Server, and in here also server. Fine. What we going to do? So first of all, let's open up the proto thingy. Types proto here. And what we're going to do is we are going to make a service. I'm going to say service. And that's going to be... God damn it. Are we going to... I'm going to call it node, I think, here. Because server is so weird. Server is node. Let's call it node here. And we're going to see. We're going to switch things up. If it doesn't make sense, we're gonna change it, right? So we have nodes. We need a couple of stuff here, and we need to do some mechanics, because I will explain later on. Because in the gRPC environment, you have this RPC protocol, but in a matter of fact, we need to have some kind of a broadcasting mechanism, right? Because if somebody is sending us a transaction, we need to broadcast that transaction to all known peers, to all known nodes, servers. In the network, and we need to do some extra stuff with gRPC to make it work. And not quite sure how I'm gonna do it. Like I said, I'm gonna do it raw and uncut, so you guys see how you actually need to engineer stuff instead of all these fake tech influencers copy pasting, and you won't learn anything, right? So we're gonna say let's make a simple RPC first. A very important one, and we're going to say it's going to be handle transaction, I think. Handle transaction. Just like that, because it always starts with a transaction, right? Handle transaction. And that's going to be, it's going to take in a transaction, which we already have, and then it's going to return none, I think. It's going to return none. Do we have none? We don't have none. So we're going to say message none. And if there is a better way to do this, let me know, actually. I'm going to do it like that. Can we actually make it? Make proto? Yes, we can. Right. And this is not quite sure. I think maybe I'm going to release this video on YouTube, this one, just to have some marketing traction for my Patreon page. But like I said, the most of these videos will be privately on Patreon, only for the Patreon subscribers, for the Patreon supporters. But if you see that this video is on YouTube, consider subscribing to my channel. Check out my Patreon if you want to learn blockchain development, or you want to learn trading, quant trading infrastructure, or you want to learn distributed systems in general. I'm also going to make a complete microservice episode series on the Patreon page. So actually, if you want to level up and you want to become a top tier, high value software engineer, consider checking out my Patreon page, because like I said, I'm from a complete other level. Okay, cool. So handle transaction. That's that. We're also going to make something like an RPC. I need to check that out, basically. And that's some kind of a version RPC, some kind of a handshake that needs to be done so we can add that connection to our connection map in our server. Something like that. So let's do some prototyping real quick. So we have this handle transaction. We made our proto. That's fine. So if you go to server right here, what we're going to do is we're going to say that the ln is going to be a net listener. A net listener, just like that. And then we're going to also maybe have some kind of a listen adder, which is going to be a string. We're going to say func new server. Actually, server new. New is fine. Maybe a listen adder here, which is going to be a string. We're going to return a pointer to this thing. And then we're going to say that the ln r is going to be net listener. Listen, actually. We're going to listen to the listen adder. And no. I think TCP is fine. We're going to listen to the listen adder here. We're going to return an error. Error. Just like that. And we're going to say if the error is not nil. And like I said, we're going to make this thing fast as fuck, right? We're going to first build it, we're going to have a consensus, and we're going to make it fast as fuck. And we're going to benchmark it and let everybody sit down in the blockchain community, because they are money hungry, but they are not. You will see. So if there is an error, we're going to return nil for the server, and we're going to return this error here. And then we have a listener, so we could say, then we can actually return this thing. So we're going to return pointer to the server. We're going to say that the listen adder, do we care about this? Maybe we care. The listen adder is going to be the listen adder, you never know. Let's return nil here already. And then we're going to say that the ln is going to be the ln. I'm thinking because... Okay, so basically how GRPC works is we have this proto. I think we're going to change stuff up, but I'm trying to figure out on the fly what a good approach is. So we have this handle transaction, right? And this is a node. So we need to create... First of all, we need to create our listener. Then we need to create our GRPC server, which will take in a GRPC server itself, but also it will take in some kind of implementation of this node, right? Something that can serve, but also something that can handle the implementation of this service. And in this case, it's only handle transaction. So, a couple things we could do. Still not convinced about this server naming. Also not convinced about the node naming. So, let's keep that open. But what we should do is, let's say we're going to implement this, right? So we could do something... To be honest, what we could do, I have some good ideas actually. So let's say func, let's call this n. What's going on here? Actually, guys, listen. Let's delete everything. Change of plans. Change of plans. I'm gonna call this node. Don't care about anything here real quick. We're gonna call this node, and we're gonna say handle transaction. Handle transaction, we're gonna implement that. Handle transaction, we're gonna say a CTX. It's important that we have the CTX because we're gonna get our peer later on from this context. A lot of people don't know, but you can extract information about the peer that is calling this thing from the context. So we're gonna say context.context. And then we're going to say it's going to give us a 3x, which is going to be a pointer to a proto.transaction. And it's going to return basically a pointer It's gonna return a proto none. What's going on? He's still rusty and an error, right? That's what's going on. Error. And in this case, we're gonna return nil and nil. So that's fine. So this node, actually, what we also need to do is do proto unimplemented node server. That's fine. Node server. Maybe blockchain server. Anyway, I'm a bit of a... I have an OCD on naming sometimes. So sometimes it doesn't make sense, but sometimes it has a big OCD. So what we're gonna do is we gonna make... Let's close all these things. We're gonna make a new file. I'm gonna call it main. And we also could make a package CMD actually. But we're not gonna do it right now. First things first, guys. First things first. So we're gonna say package main here. We're gonna say func main. And then we're gonna say something like GRPC server error. Is it an error? I don't think so, to be honest. It's going to be grpc.new server. We need options, so we're going to say it's going to be a slice of grpc option, just like that. We're going to put the ops in here. Let's see if it works. It doesn't. Let's do this. That works. What is this? grpc. Is it call option then? What kind of option is it? Client, compressor. I think it's call option. We will see. Opt, and then we need to spread it out here. It isn't. What's going on here? I cannot use. It's a server option. Oh, yeah. Didn't see it actually. Alright, now we're Gucci. Then we have this gRPC server, and what we need to do is we're going to say gRPC server serve, right? And then we need to specify a node and a listener, right? You see, oh, actually only a listener. I don't think it's true, to be honest. So let us create this node real quick. We're going to say node, and let's rename this back to node. Hey, going back and forth, guys. No worries. That stuff happens. This is going to be node, package node. We're going to have some issues for some reason. Package node. Package node and server. What's going on here? I think a problem is, let's close this guy. Let's open up Node real quick. Node here. What's going on? Why is this not working? Why is it doing dirty? No clue. It doesn't really matter. Let's make a constructor real quick. New node. Which is going to return a pointer to a node here real quick. We're going to say return n node n. What's going on here? What's going on? N node. We're not going to do anything here for now. Node, new node. And I think we need to serve the a listener, and let's make a listener real quick. So we're going to say ln r is going to be net listen. We're going to listen to TCP, and then we're going to say, let's say port 3000. We're going to make everything configurable. No worries. Let's say if r is not null, we're going to just log fail out the error from the listener actually. And then we're gonna say here, I think it's ln, but we also need to specify. What's going on? GRPC. I think we need to register it first, to be honest. If I can remember. So we need to serve the ln, that's true, but we also need to say something like proto register node server, that's the thing. And we need to specify our RPC server and then our node. That's it. And then we can serve it. And let's make something very simple. We're going to say fmt. I still need to figure out what kind of logger we're going to use. We could use Logrus, which is basically one of my favorite loggers, but it's slow. It's a slow logger. It's we could use something like Zap, zero allocation logger. We will see. Let's just do something like a println. Or yeah, println is fine here. Server. You could say blockchain or node actually. Blockchain is so cheap. Node running on. What's going on here? Running on ports, and then do this. 3000. Alright, so the node is running on port 3000, which is actually not that fancy. So you can see this is a dirty stuff going on, but we are going to fix that very soon. And you see this still has its VS Code still basically crying about things you didn't know. So we're gonna go back to types here. No, I want to show you guys something real quick. Let's go to nodes. So in this implementation, right? So what we're gonna do in this case, we're gonna have let's clear it here and here. We're going to have a map of peers, right? You could say peers. And it's going to be a map of a good question. It could be a net adder or something with some kind of a gRPC dialer. Client. That's what's gonna happen. Client con maybe? Or even client. Something like that. This is GoKit. We don't care about this. Client con maybe. Something like that. So basically, that's what we're gonna do with a mutex, of course, or maybe with some kind of a channel. So we don't need a mutex because mutexes are basically an overhead, complicated stuff we don't want. Not complicated stuff, but it's always an overhead, and we want to make it fast. We will see how we fix that. That's what we're gonna do. So basically, when we handle a transaction, we can actually broadcast this to all the peers we have, all these gRPC connections, right? That's what we want. And how we are basically going to put these peers into a map is because in each time we handle a transaction, we're gonna check. Actually, we don't care. Yeah, we're gonna check basically if the guy or girl, the thing calling our handle transaction is actually in this peer map. If it's a registered connection, because we want only registered connections, known connections to the server, known peers to the server that doing that stuff. Of course, we're also going to add some kind of a JSON RPC server, so everybody can just publish a transaction actually into the network, but that's for later on. So, okay, cool. So the thing is, can we actually test this real quick? How are we gonna fix that? Let's make some mock service like make transaction or something. Make transaction. You don't care, it's just for testing. So we're gonna say that the client error is gonna be gRPC. Client. Is it the client stream? You don't need a client stream. Dial. Okay. Can we do this? Let's see what's going on. Let me if add is not nil, we're gonna log fatal out this error, and then we have a client. Do we need to register that stuff? I'm trying to figure out stuff, right? I see it's a new node client. Is it like this? Let me see. It's gonna return a node line. Yeah. And then we could actually just call that stuff handle transaction. I don't like the name handle transaction, to be honest, because nah, need to think about that. So we need to give it, what do we need to give it? A transaction and a context, is that true? I'm gonna say context to do or something. And then we're gonna say here proto transaction real quick just to make it dirty. And that's gonna return actually nothing. If r is not nil. Like I said, this is basically setup, guys. This is a setup episode. This is going to be a pilot episode into the GRPC stuff, where we're going to figure things out. So we're going to say log fatal. Once again, log fatal error, and let's see, why is it complaining? I have no clue. Basically new variables. It's because there was already an error. It's all good. It's all good. So make transaction. That's fine. We're gonna run this thing here. That's also good. What we're gonna do? GRPC listener proto register serve here. What we're gonna do here is go make a go routine, just like that. We're gonna say time sleep. I don't know how many seconds. Let's say 2 seconds or something. Time second, just like that. And then we are going to make a transaction and see what's going on. To be honest, can we do a for loop? Yeah, we can. Let's do it like that. Okay, cool. Now we're gonna actually go to our node and see what's going on here. FMT. Received TX from CTX. We can do that. We could do peer underscore is going to be peer from context CTX, and then let's put in the peer and see what's going on here, right? Go run main.go and let's see what's going on. Node transport security set. Okay. With insecure is it, right? I think it's with insecure. GRPC with insecure. Is that a thing? Can we do this? We can't. We can't. It is deprecated. With transport credentials. We don't care. It's going to be that. And we're going to fix everything else later on. Okay, with insecure is basically a dial option. So we're going to do it like this. What's going on? Let me quickly see how we do this dial shenanigans. I don't know on the top of my head, and I don't want to spend too much time for it. Let me quickly see in one of my Golang micro projects where we're already doing some gRPC stuff, gRPC server, to see what we need to do. Options. Okay, it's probably in the client, right? It's in the client. Let me open up the client. Okay, it's a function. I'm legit garbage. I thought it's just a function. It's good. It's not a thingy. Okay, cool. So we have an error. Desk marshalling proto. Okay, cool. So I think the problem. Let's first of all make proto real quick. I don't think it's going to be the problem. I think the problem is that this gRPC transaction is going to be empty. I think that's the problem. So let's do a TX, which is going to be n proto transaction. We don't care about these other things. We're going to say the version is going to be 1. Version of our transaction. And then instead of doing this, let's do that. Clear it out. Go run main.go and see what's going on here. Again. Okay, so we received marshalling. Proto marshal called with null. Received the X from, that's fine. Ah, I see what's going on. I think we need to. We can't. We need to do this. We need to say it's going to be n proto none. That's what we need, I think. Normally in an RPC environment, you want to respond, right? That's the thing. Okay, now it's working. So in a gRPC environment, you actually want to respond, right? So each time it's an RPC, right? You send something and you expect to receive a response, but in this case, it's not gonna happen yet. Well, actually, we respond something, but it's like an acquired, maybe. Maybe we could, instead of none, we could say an acc. Like, hey, yo, it's fine. We got your transaction, we handled it, it's good, instead of none. Maybe that's a good thing. Let's do it like that, right? Let's open up types proto, and maybe some gRPC gurus will know a better way. But let's call this an acquirement, right? And we don't need to specify anything. It's just an empty type to say that we acquired it, right? Let's make proto real quick here, boom, and then open up node once again, and then we're gonna say a proto acc. Proto acc, and then here we're gonna say what's going on here. We're gonna call this a proto acc, just like that, and then everybody is happy, right? Cool. Okay, so we have a very nice basic of our gRPC. The next thing we're gonna do is what I think we're gonna do is open up proto thingies real quick. We have this handle transaction. What I want to do is RPC, and I want to call this this handle transaction. Not quite sure if that's the name we're gonna pick, to be honest. Let's call version. I like version. And what I'm gonna do is we're gonna exchange versions between servers. It's some kind of a handshake, actually. So we're gonna make this version here, and we're gonna make this file better later on. We're gonna say version, and we're gonna say, or maybe we're gonna do handshake. Maybe that's better. Handshake. Yeah. It's going to be, what is this version? A UN32. It's going to be an in32 version. Actually, we can, it needs to be small caps. It's going to be 1. Do we need something else? Of course, maybe we're going to say an int32. It's going to be a height. It's going to be 2, something like that. So what's going to happen here is in our protocol from our nodes, what's going to happen is that before we are going to connect to a node, we first need to gonna do a handshake, which is basically, you could call it version, you could call it handshake, whatever. It's basically some kind of a way to basically shake hands, if you know what I mean. They want to get to know each other. You know what I mean? So if I want to connect, I'm node A, and I want to connect to node B in our blockchain. What's going to happen is that I'm going to send a handshake. And in this handshake, I'm going to call that handshake RPC method from GRPC. And I'm going to send a handshake structure, a handshake message. And I'm going to specify my version from, hey, B, I'm A. This is my version, the current version of the protocol, of the node, the current version of the software. This is my current height. And some other stuff, right? On the other side, the node is going to respond. It's going to say, oh, this is version 1. I'm at version 1. So it's fine. And then it's going to say, oh, his height is less. Then he can basically check from, okay, I'm almost full of connections. He is lower than me, so fuck him. It's not an interesting node for me because I'm already full, I'm already on load, and he's gonna basically need to sync with me and all that stuff, so no. On the other hand, they could accept them. Then we're gonna resend our own version. Right? So I'm A, I'm going to send my version, my handshake to B. B is going to respond with his version because it could be that node B is lower, his height is lower than our height. Maybe we are at block 100, but the server we are connecting to is at block 50, at height 50. That's a bad node for us. Why would we connect with that guy? Right? Because we cannot sync with him. He needs to sync with us. Of course, in an ideal scenario, everybody wants to connect with everybody, so everybody can actually sync with each other and go be at the height everybody needs to be. But most of the time, when you're full, you don't basically want to connect with nodes that are lower than you because they don't provide any benefit. But that's when we're full of connections, right? You know what I mean? Just giving you some ideas here. All right, so we have this handshake. Probably gonna have some more things here, but version height is perfectly fine. So we're gonna say it's gonna have a message handshake, and we are gonna return. In this case, returns also a handshake. Right? We're gonna get a handshake, gonna return a handshake. And actually, to be honest, that's my caps lock on. What's going on here? VS Code, what is going on here? Jesus Christ. Oh, yeah. Okay, let's do this. Handshake here. Boom. It's gonna be handle transactions sometimes, man. What's going on? Why is this? Handshake is not a message type. What is it then, man? And I'm thinking, what I'm going to do here, I'm going to make a version type here, to be honest. It makes more sense. A version here. That's fine. Make proto. All right. Cool. So, handshake. Version, fine. So let's go to Node, because Node does not implement what we need to implement. We're going to say func. Let's clear these screens here. We're going to say n node handshake with a CTX, going to be a context. We're going to call it version, actually message or version v. proto version, and we're gonna actually return a proto version and an error. Just like that. Let's return. So let's give this guy a version which is gonna be. It's gonna be an int, right? A uint actually, but it doesn't matter. Let's say it's gonna be version 1 for now. I think a string is better, to be honest, in this case. Because if it's an int, we cannot do this, right? We cannot increment this stuff. So maybe we're gonna call this. Let's make it a string. Of course, we are in trouble because now we need to go to our proto, and we're gonna call this. Do we have a string type in proto? Probably we do. Yeah, it is. Make proto real quick. Boom, it's already been done. Then we're gonna say we could do something like blocker 1, 0.1 or something. I don't know. You tell me. It's gonna be the version, and then we the current height we don't know. We don't care. So each time we get, let's clear this out. Each time we get a handshake, we're gonna make our version, like our version. It's gonna be. Let's mock things out, right? So we're gonna say it's gonna be an n proto version. We're gonna say this version is gonna be n version, and then the height we don't know. We're gonna say 0 because we don't have one. Actually, let's mock it out. We are at 100. It doesn't matter. That's our version. We're gonna return our version null. Right, and in this handshake basically determines if we're gonna accept that connection, yes or no, right? Because like I said, we're gonna maintain a map of GRPC stuff, and actually, I have so good ideas, but it's gonna be for the next episode. To be honest, it's gonna be so insane. We're gonna actually maintain a map of these node client cons, which we can directly call handle transaction each time we need to broadcast. It's gonna be insane. So this is our version, but we're gonna also log out println. We're gonna say actually printf maybe. No, we're gonna say received version from. Let's call it f. Received version from %s. And then we're going to say percentage plus v maybe or something. We're going to call a /n backslash, not a backslash, new line. And that's going to be the v. The v is what we receive. This is what we respond. What's going on here? Oh yeah, I see. We need to have... damn it. Peer from context ctx v peer remote. Actually, be remote adder. Fine. Is it a function? No, it isn't. It's fine. All good, all good. That's the handshake, and then we're gonna do some logic later on. Let's first test this real quick. So instead of making this transaction, we are gonna make a version. It's gonna be an n proto version. It's gonna be a blocker 0.1, height 1 or 0, we don't care. Then we're gonna say instead of calling handle transaction, we're gonna call version. Handshake, I mean. Not handshake, man. Handshake. Context to do, and then we're gonna say this version thingy, and then we're gonna call it a day. Go run main.go. Received version from blocker. Yes, so it's working. So I think we are set up with our gRPC shenanigans. The next episode we are basically gonna create client node client cons, put it into a map of peers so we can actually broadcast stuff. Yeah, and then we're going to create transactions, and then we're going to make our blockchain type struct where we're going to store blocks, create transactions, validate all that stuff. And yeah, man, it's looking good. It's looking good so far. All right. If this video is on YouTube, consider subscribing to my channel. Give me a thumbs up. And if you want to be a high-value software engineer that basically knows everything about core blockchain development, you can create all these things yourself. Check my Patreon page, become a Patreon supporter, jump into the Discord, and level up as an engineer. And I see you in the next one. Peace.